Hi, my name is Premnath Kaudaman, son of Kaudaman. I'm from a BEA 2/1. So today I'm here to present about my bachelor degree project. So in this video, I'm going to present two things. The first thing is the introduction, objective, methodology, research methodology, result, conclusion, all in a we in a poster form. The second thing is I'm going to show the demonstration of my project. So don't miss it, watch at the end. So now I'm going to share the poster first. So if you see, so this is my poster. So my project name is development of a IoT based on an ankle exoskeleton for the ankle rehabilitation therapy monitor. So what is this project about? So this project is about monitoring the ankle recovery status with a ThinkSpeak and a Blink application. These two applications, ThinkSpeak and a Blink application, is an IoT platform. So the user of the project or the orthopedic doctor of the project can monitor their ankle recovery status through their smartphone and able to access their data from the server cloud. Server cloud. That means orthopedic doctors or the patients, they can extract the data from the Excel form at any time for the future preference and a reference. So second things I'm going to use this will present is the objective. So the first objective of my project is to develop a system and data system on an ankle recovery using a mobile application and a web server. So second thing is to monitor the real-time graph of an ankle recovery. Third thing, save the data about the ankle recovery in a cloud storage which can be accessed in the future if we needed. Third thing I'm going to present is the research methodology. So what kind of the research I've been going through to make success this project. The first thing is I've been go to the Arduino website to get know the knowledge of coding and then the C++ language. Second thing is I went to the ThinkSpeak website. This ThinkSpeak website and teach me a lot about the real-time graph and how to connect with my sensor and with my microcontroller. Third thing is YouTube. YouTube videos is to ensure the connections, to get the knowledge of the connections with my microcontroller and a sensor. So this is a research methodology that I have been go through. This is before I'm continue with my result discussion, I'm going to say that I'll be using a sensor and a microcontroller. So my microcontroller that I'm using is Note MCU. The sensor that I'm using is Cryo sensor. So this is a result discussion. So in this section, I will explain the result, how the ThinkSpeak update, how the data from the sensor updated in a ThinkSpeak and a Blink, which is a IoT platform. So first of all, this device is working on a battery powered supply. So this device can be carried by anyone with a low cost, and this is also a portable device, which means they can be wearable at any shapes or any shape of the leak. So other than that, I'll show the before I'm showing the result, or the examples of the result that will be updated in a ThinkSpeak IoT platform. I'm going to explain the ankle movement in a scientific name. So the ankle movement for there are three axes for the ankle, X, Y, Z. These are the three axes. So these three axes, they have a specific name with a range of a rank movement. So for the ankle, for the x-axis, which means the x-axis, this is a leg, for example, this is a leg. The x-axis will move like this, and a y-axis will move up and down, and z will be moved horizontal with the left and right. This is a leg. So for this x-axis, they will known as a invasion and a evasion. For the y-axis, they were known as dorsiflexion and a plantar flexion. For z, abduction, adduction. These are the 6 degrees of freedom for the ankle. So now I'll show the example that been updated in a ThinkSpeak. So this is the example graph, real-time graph that been updated in a ThinkSpeak. So there are 6 degrees of freedom: inversion, eversion, length of flexion, dorsiflexion, abduction, and adduction. So this is the example that being get in a Excel form. So the orthopedic doctors or the patient who need their data in the future, they can download it from the platform, IoT platform, and get in a Excel form. So this graph we display in a angle recovery versus time angle. So this is my flow chart of this project. So this is the flow chart. First thing is we need to start the turn on the device. After that, that's an input module. That's an input module means the sensor. This is the sensor. The microcontroller that I'm using is a Note MCU. After the after these both connected, there be a connection Wi-Fi. This connection, if the success, the MPU sensor reads the value from the movement of an ankle, movement of patient of the ankle, updated in a IoT platform and a smartphone. So if they need it in the future, they can be downloaded to the cloud. So this is the end of my flowchart. Hi, now we go to the demonstration of my project. If you see, this is my circuit. This is a Note MCU, MPU 6050 sensor, battery supply, switch, and a LED. This is a wearable for the ankle. So now I will show how to fix this wearable to the patient. First, you take the wearable, fix to the patient's leg. Next, we fix the device to the ankle. Been fixed to the patient's leg. And this is the front view of my project. This is side view of my project, top view and a back view. So now I'm going to turn on the device. Once the push button being started, this LED will be turned on. That means the device is turned on now. So before I'm going to the demonstration of the ThinkSpeak, I'm going to explain there's a 6 degree of freedom in an ankle. So the first one is a inversion, second one is a eversion, third is a dorsiflexion, fourth is a plantar flexion, fifth is a abduction, and a sixth is a adduction. This is a ThinkSpeak. So you need to sign in the ThinkSpeak. Once you sign in the ThinkSpeak, this is my ankle rehabilitation therapy monitor in a ThinkSpeak. So this is how the data will be updated in a real time. Once the patient lift upwards the ankle, this is known as a dorsiflexion. So the data will be displayed on the ThinkSpeak. This angle movement is known as a plantar flexion. The data will be displayed in a ThinkSpeak. So this is the data for the plantar flexion and a dorsiflexion. So when dorsiflexion, the graph will increase, and when plantar flexion, the graph will be decrease. This is the known as a inversion movement in an ankle. So the data will be displayed in a ThinkSpeak. This is the eversion. The data will be updated in a ThinkSpeak.
This is how the graph will be shown in ThinkSpeak. This is the evasion and this is the invasion.
So from the horizontal position, if the patient's ankle moves to the left, that's called as a adduction. This is known as an abduction. The data will be displayed in a ThinkSpeak.
So this is the abduction and adduction movement, the graph, real time graph. When abduction, the graph will be increased, the adduction, the graph will be decreased.
As a conclusion of my project has been achieved the objective. So my objective is first is I will to develop a data system on ankle recovery using a mobile app and a web server, which is I have created an IoT platform in a mobile app and also IoT. Third thing is to monitor the real-time graph of an ankle recovery. Then also can be real-time graph. Third is can save the data or extract the data from the cloud. So this is an example that can be extracted data. So the goal of this project has been achieved. That is providing an platform, an IoT platform for the ankle injuries patients to monitor their recovery status through online and via smartphones. I would like to take this opportunity to thank my supervisor, which is Muhammad Razali, Engineer Muhammad Razali. Other than that, I would like to thank my panel, Engineer Azmi and Engineer Aidil. Thank you for watching.